So our next piece of work is to write a piecewise function for the graph. So looking at number 14, I hope you can see that you have two branches here. And you sort of want to see what the critical value is. So the critical value is sort of where your open or closed circles or your sort of pieces of your graph end. So hopefully you can see that that occurs at x equals 0. So I'm going to name my graph f of x. In looking at this, I can see that I have a piece for when x is less than 0. And I'm choosing less than instead of less than or equal to because I have an open circle. And then my second piece is for when x is greater than or equal to 0. Okay, because right here, when x is 0, this is the point that's included. So looking at my piece to the left, I can see that it's a line. For me, I can see, to me, this slope looks like it's about, I'm trying to see where a point looks like it really goes through. To me, it looks like it's negative 4 over 3, so negative 4/3 x, and it has a y-intercept of 0. Okay, so plus 0, or we wouldn't write that plus 0. And then for my right branch, the value right here is 3. Okay, so this would be the piecewise function f of x equals negative 4/3 x for x is less than 0, and f of x equals 3 for x is greater than or equal to 0. When you write this, you need to make sure that one of the most common mistakes is including both doing an inclusive inequality, so x is less than or equal to 0 and x is greater than or equal to 0. Remember, in order for it to be a function, only one of them can be included. Okay, now for our next function, this time I'm just going to name it g of x. Remember, that's arbitrary. You can name it whatever you'd like. And I can see that there are 3 pieces. My first piece goes from when x, this is negative 3. It includes negative 3. And it ends at 0, but 0 is not included. And that is the horizontal line y equals 3, so that value is just 3. Now, next, I go from 0, which is included, right, closed circle, to 1, which is also included because it is a closed circle. Okay, and I can see my y value there is 4. For our next one, this starts up when x is 1, but it's an open circle, so it's not included. And it ends when x is 5. And since that is a filled in circle, we're going to use or equal to. And this is a line. It has a slope of 1, so that's 1x. It has an intercept of 0, right? If I extended this line, my y-intercept would be 0, so this is just x. Okay, I'm noticing one other small thing sort of for notation. Anytime we give the function, we sort of separate the function part and the inequality with a comma. So I'm going to do that on both of my functions. All right, our next one. A postal service charges $4 for shipping any package weighing up to but not including 1 pound, and $1 for each additional pound or portion of a pound up to but not including 5 pounds. Packages 5 pounds or over have different rates. Write and graph a step function that shows the relationship between the number x of pounds of a package weighs and the total cost y for the package. So I'm going to just sort of think about this for a second. So I'm going to have X and Y, and the Postal Service charges $4 for shipping any package weighing up to but not including 1 pound. Okay, so that means anything, well, first of all, when it's 0 pounds, it's not going to cost us anything, right? Because they're not going to charge us anything. But then from 0x to 1, it's going to cost us $4. But then it costs an additional $1 for each additional pound or portion of a pound up to but not including 5 pounds. So that means if it's 1 pound to just under 2 pounds, it's going to cost us an additional dollar. So that would be $5. And then if it's 2 pounds to just under 3 pounds, it's going to cost us an additional $1, which would be $6. Similarly, from 3 to 4, it's going to cost us $7. And from 4 to 5, it's going to cost us $8. Okay, and then packages 5 pounds or over have different rates. So we're only going to be able to graph this step function from 0 to 5. So I know that I can't have any negative values for my pounds or my cost. So I'm just going to have this be 0 and this be 5. And then it looks like I need to get all the way up to 8. So 2, 4, 6, 8. I'm going to make this 10 up here. Okay, so first we're going to plot the point 0, 0. Then from 0 to 1, for x is 0 to 1, it's going to be 4. So up here, it's going to be an open circle, right? Because they're not going to charge me $4 if I don't have a package. So it's going to be an open circle there, and then until I get to 1, but including, or up until 1, sorry, so that means 1 is not included. We're going to have open circles like this. Then from 1 pound to 2 pounds, it's going to cost me $5. I forgot that I had changed my scale. Then the next one will cost me $6, then $7, and then $8. Okay, so this is a real life application of a problem that you might see that they use for a piecewise function. And I think you can also see why they call this a step function. Okay, you can kind of see the steps, the incremental even parts that you're stepping up for each interval. Please make a note of any questions you have, and you can ask them the next time we see each other.